Because I'm recording you.
So let's not talk about
Okay. So, in the last section, we learned how to do areas. Okay, so that was the area of two-dimensional space. So today, we are going to go three-dimensional and go into the idea of volume. Okay, so the first section that I cut this into two sections. We're going to have a part 1 and a part 2. The first section is using cross sections. Okay, so what I want to explain to you about what a cross section is let's say we were going to find the volume of this. Okay, so if I was going to kind of turn this sideways and say I'm just going to lay it flat, and I was going to cut a perpendicular cross section into my mug, what shape would the cross sections be? Circles. Okay, so if I can figure out the cross sections, I can just use that shape, so the base would be a circle, and then I would use the equation of the height to come up with its volume. Okay, so you can see that this wouldn't be a perfect like linear cylinder. It's got some curvature to it, so it would be a more complicated equation than just a cylinder. See what I mean by that? You got a question? You just, oh, okay. You're, oh, perfect.
I was
thinking about one function defined from here to here, and another function defined from there to there, and a piecewise function.
Oh, yeah, we're not going to get that complicated today.
Okay.
Not today.
So I'm going to go now. I can walk up, but you didn't go that complicated.
Yeah, we're not going to listen to Miss Ruff right now.
Oh my gosh.
Okay, so clearly things can be incredibly complicated when we start talking about volumes. Okay, but today we're going to keep things nice and simple. We're going to use cross sections that are pretty shapes. Okay, like circles or squares or rectangles. Okay, so the first thing we have to think about is, do you know the area of a square? Side times side, right? Which side squared would be equivalent to a square? Okay. Area of a circle? Pi r squared. We good? Okay. So here is my first example before I go in and do an example with you using the calculus. Okay, so let's pretend that this is my base area. Okay, so let's say I have a top function. Let's just say this equation might be y equals 5 or 2, sure. Okay, this bottom piece might be some kind of parabola, right? That makes this shape, right? Okay, so we could have a top minus a bottom scenario. Okay, so I would have my base area. Okay, so now what we're going to do is we're going to create a volume by putting an infinite number of squares upon the base. Okay, so my cross sections are going to be squares. Okay, so you ready to visualize this?
No.
Okay, so this is just one single square. I didn't cut out an infinite number of squares. Okay, but imagine that there are an infinite number of squares coming out of this base. So the base length of each of the squares is the distance between our top equation minus the bottom equation. Okay, so you can see my biggest square is going to be the one that's between here and here. Do you see where I'm at right here? That would be my biggest square. Okay, the closer I get to this little corner right here, the smaller the little squares get. Okay, so I have an infinite number of squares creating this volume, this three-dimensional shape. Do you see it?
Kind of.
Okay.
It's kind of hard to remember.
Okay, so all we need to know to find the volume of something is that all we're going to do is we're going to take the base area times its height. Okay. All right, so here is my first example. Are you ready for this? Okay, so the first question that I have here is very similar to what I just showed you. Okay, I'm going to start by drawing the base area onto my two-dimensional surface. Okay, and that's exactly like what I just did. Okay, in our last section. So if I was going to draw my y equation right here, What does negative 1/9, focus, 1/9 x squared plus 4 look like? It's a parabola. It's like upside down. It crosses the y-axis at 4. Can you tell me where it crosses the x-axis? Well, it's upside down, isn't it? If I set it equal to 0, I could figure this out, right? How would I solve this and find where it crosses the x-axis? We don't need a calculator. Come on, we're smarter than that. When you subtract 4 first, good. So we multiply by 9. What's negative 4 times negative 9? 36. And the square root of 36 is 6. So yes, you're right. It crosses at plus or minus 6. Okay, so this is our very fat parabola. Okay, and then also it's going to be enclosed by y equals 0. So what does y equals 0 look like? Yeah, it's like literally the x-axis. And a lot of times they'll, instead of using the equation of y equals 0, they'll say and the x-axis. Okay, so this is the area of my base. Okay, so just kind of like my little thing that I have here. Okay, and then it says to us, it says, we're going to have cross sections that are perpendicular to the x-axis, and they create squares. Okay, so we got squares. Look at my little example, just perfect. Little squares. Oh, we'll do an example. We'll do more examples. Okay, so in order us to find the volume of something, okay, this is what you need to write down in your notes. Right here. To find the volume, all we're going to do is we're going to take the integral between our bounded region, just like we were doing before, between A and B, but we're going to use the area of our cross section. Okay, so this right here, this A of x, is the area of the cross sections. Okay, so if I go, good? Okay, so if I go back to my example here, the first thing that I have to figure out is the area of my cross sections. Okay, what is the shape of the area of my cross sections? They're squares. So how do you find the area of a square? Okay, and on a square, those are both the same, right? So give me a better equation than length times width.
L squared.
Okay, can I use s squared? I just like s because it stands for sides.
If you really wanted to, I guess you can do that.
Okay, so imagine that I'm going to lay this square. Do you see where I just kind of picked, I don't know why I picked 2 exactly, but okay, the base length is a little square. So can you see I'm drawing this picture here? It's coming up. That's my square coming up at us, right? Okay, so what I have to do is I have to figure out the length of this side. Okay, so tell me what the equation for the length of that side is. What's that height?
4.
Okay, how are you getting 4? Don't assume my drawing is drawn to scale. 2. Okay, what if I wasn't using right on 2? Okay, let's say instead of using it right on 2, that was kind of a, I see where you were trying to cheat. Let's say you didn't know where I was at. Let's say I was over here somewhere. What would the height of that be? How would I know the height from here to here? It would be the height of this equation, right? Okay, so my base length of every single square is going to be negative 1/9 x squared plus 4. Oops. Okay. You see that? So all I did is said my S, my side length, is the height of the parabola. Right? Because this square isn't always going to be in one specific spot. It's an infinite number of different spots. So I need an equation because it's a moving thing. It's not set in stone.
Wait, are they always going to be squares?
Nope, not always squares. We'll do other examples. I'll show you more. Okay, so now here's the part where I'm going to do the integral. So remember the definition that you just wrote down was we're going to do the integral from A to B of our area. Okay, so I need to know the base length, where does that exist between which two x values? Okay, so it exists between 6 and negative 6, so my smaller value goes on the bottom. Okay, and what is the equation of the area? Negative 1/9 x squared plus 4 squared. Okay, so today I'm going to let you use your calculator to do the integration piece, okay, because I want you to focus on the setup because right now that's the hard part of this. Okay, so grab your calculator, make sure you know how to type this into your calculator. Okay, it's not necessary for you to use a calculator, but it will certainly be helpful on this worksheet. So we're going to go from negative 6
Oh wait, how did you get
to
there?
6. You hit alpha window. Okay, and notice on this one I have to do a quantity squared, so I'm going to need a second set of parentheses. So I'm going to go parentheses, so I have 2 right there. I'm even going to throw in a fraction so it looks identical. Negative 1/9 x squared plus 4, and I'm going to get on the outside of that, whoops, just kidding, I'm going to do a parenthesis and then hit squared. Is everybody okay with that squaring piece? Make sure you do that correctly.
Oh, I see. Wanted to know.
Okay, so I got an answer of 102.4.
That's what I
Did anybody else get that? What are you doing?
That is not my calculator.
What do you hide my calculators?
I just knew one was there from my friend.
Where else are they hidden?
It's almost Easter Day.
Oh, is that what inspired you?
Oh, I didn't put it in.
We did not get to do this.
All right, we good? Everybody okay with that setup?
Are we good? No, we understand it maybe.
Okay, let's try another one. What? Oh, you like that? Because I got yelled at last time for doing that.
Well, that's what you asked.
512. You're right. I'm not disagreeing with you. This. Okay, ready for a second one?
That's the answer.
That's the answer. So that's a volume. Okay, if I was going to use some kind of units, I would be saying my units would be cubed. 3-dimensional space there.
What's you?
Units. Because I don't have any units. Like if it was in centimeters or something. Alright, number 2. Okay, so we have the base of our region is going to be a semicircle with the equation, the square root, sorry, this didn't come all the way off, the square root of 49 minus x squared, and it's also bounded by the x-axis. Then our cross sections are going to be perpendicular to the x-axis, and they're going to be rectangles with heights that are half of that of the side of x.
I don't like this.
All right. So first thing we're going to do is we're going to draw the equation. So does anybody know what the square root of 49 minus x squared looks like?
Yes, I do.
Yeah? What does it look like? It's a semicircle. It is exactly half of a circle. Do you know where the center point is?
I'm gonna say.
Good guess. Yes, you're correct in the center point being 0. Do you know what the radius is?
Ridiculous, bro.
Hmm.
7.
Very good, yes. So the radius of this circle, so by the way, do you see this right here? Do you guys remember x squared plus y squared equals r squared, equation of a circle?
Nope, I didn't.
No, there you go. So this is just simply isolating the y, and it's the square root, so it's the positive, so it's the top half of your circle. Radius is 7. You're going to see that again, so if you didn't know that, you might write yourself a note about the equation of a semicircle.
What's a semicircle?
Semicircle. Okay, and it's also bounded by the x-axis. Okay, so our base length looks like that. Okay, you ready for the cross-section
What's
part?
the equation that x squared plus y squared equals r squared?
That's just the equation of a circle.
That's just the
Yep.
But that's semicircle, right?
Well, this right here is a whole circle, but this right here is solving for y. So like if I was going to have the whole piece, you'd have a positive and negative square root. Whoa, what happened there? So that's why, since it's only a positive square root, it's only the top half. Yeah, square root of 49. All right, here we go. Perpendicular. So the shape that we're going to be doing for our cross sections are rectangles. And a very important piece of this is that the height is half of that of the side. Okay? So the first thing we need to think about is, what is the equation for the area of a rectangle? What's the area of a rectangle? This is not a tough question. Area of a rectangle? Base times height, right?
Yeah.
Base times height. So I'm going to say, we can use a base times height. Okay, so the base length is going to be the base between the x-axis and my semicircle. Are you guys with me?
Yes, I am.
You see where I'm drawing? Okay, so what is the length of my base? What is this base length? What do you mean by that? Okay, so this height is going to be the square root of 49 minus x squared, right? So that's your base. Okay, so my base is 49 minus x squared. So now, what is my height? Remember, my height is half of that. So how would I represent that height? You guys, shh, 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 shh. Listen. Okay, so my height would just be 1/2 times the base, right? So 1/2 times that base. Does everybody follow where I got that? Okay, now I might just go ahead and simplify this just a little bit because I have two quantities that are identical that are being squared or multiplied by each other, right? I have a 1/2 in there. So this is going to become 1/2 times what? Okay, because the square root cancels, right? Because I'd have a square root being squared. So it's just going to be 49 minus x squared. Is everybody okay there? Because I have a square root times a square root, which makes a squared. But if I have a square root squared, they cancel out, right? So that's why I don't have the square root there. Okay, here comes the integral part, the volume. So the volume is the integral between which two values? Good. -7 and 7. Times my area. So what's my area? Or of my area? That blue piece, right? So 1/2 49 minus x squared dx. Okay, so go ahead and grab your calculator, type that in, and tell me what you get. Say again, 228. Oh, 0.6. Will you hit fraction for me? Math fraction.
686 over 3.
680 over 3?
686.
Oh, 6. Over 3. Is that what everybody got?
Yeah.
Excellent. Okay. Let's do this semicircle one because semicircle can be a little bit confusing. We all okay? Good? Okay, so let's try this. We're going to do 2 more problems and then we'll call it good.
Okay.
So this question, I think we can kind of bust through the first part of it. The base is a semicircle, so tell me about my semicircle that I'm going to draw.
It starts at 0 and it's 5.
Has a radius of 5. Very good. Okay, so I'm just going to draw a semicircle with a radius of 5 and the x-axis, so it's bounded by the x-axis. So this looks very similar to the last question. Okay, now this time I have cross sections that are perpendicular to the x-axis that are semicircles. Okay, so this is a little bit more interesting. Okay, so since our cross-section area is a semicircle, tell me what the equation for the area of a semicircle would be. Semicircle. Area. Think area. What's the area of a circle? Okay, so the area of a regular circle would be pi r squared. But if we're going to do a semicircle, which is just half of a circle, very good, it would be 1/2 pi r squared. Okay, now think about this for a second. What is r?
Radius.
The radius. Okay, now if I look at the base length of my semicircle, what is the length of my radius? Go ahead. Yeah,
5.
straight up 5. No, wait, anywhere on the circle, like over here.
Oh.
Okay, so the height of this, or the diameter, would be what? What's the diameter from the base to the top of the semicircle? It's this, right? So it's the square root of 25 minus x squared. But if I'm talking about the radius, what's the radius in terms of diameter?
1/2.
It's half of it, right? So my radius is going to be 1/2 of that equation. Do you follow that? My radius is going to be 1/2 of my diameter, which is the square root of 25 minus x squared. Okay, so if I plug that into my area equation, we're going to have 1/2 times pi times 1/2 times the square root of 25 minus x squared squared. So you got to be really careful of your parentheses here. You guys want to simplify this? Let's simplify it just for funsies. Just for funsies, because
Yeah, because we just do
this is not incredibly hard. This is good practice for us. Okay, on the inside I have a 1/2 that's being squared. What is 1/2 squared? Square the top, square the bottom.
I'll look it up.
1/4. So then I have a 1/4 times a 1/2. What is 1/4 times 1/2? 1/8. So the 1/8 can come all the way out. So I have 1/8. I have a pi. Okay, and then I also have this square root piece being squared. So what happens in that scenario?
because the way it's 25.
They go away, right? So we just end up with a quantity of 25 minus x squared, and I would probably just leave it there. You could distribute, but I don't think that's even necessary. All right, let's set up our volume. So the volume exists between which x values for our base? Good, -5 to 5. And then we're going to just take the integral of the area piece. And somebody's going to type that into the calculator for us.
Okay, say you didn't simplify as much.
Yep. Yeah, I could have typed it in right here.
Would I get dock points for that?
Probably not. Not unless I ask you. So like on the test, if I tell you that you have to do the integral piece by hand, like today I'm letting you use the calculator. So on the calculator, it's not a big deal. But if I ask you to integrate that by hand, you're going to want to simplify it first. So I might give you like 2 problems where I want you to do by hand, and then I might give you 2 problems where I'll let you use the calculator on it. Okay.
Yeah.
The half.
like
Which
6
half are we
digits.
on? This one?
Yeah.
Do you understand where I have why I have to? Okay.
Yeah, I get why you have one.
This
Why
one?
87, I get why all.
Okay. So if you're gonna look at the semicircle, so imagine that I have this semicircle, right? Placed on here. Okay, but the area for a semicircle is pi r squared, the radius, right? So the radius is only half of the distance of the diameter. Okay, so the distance from here to here is the square root of 25 minus x squared. Right? The distance from here to here. But I want a radius because this equation is in terms of radius, which is half of that distance. Does that make sense? What do you get?
It's like 5,555,000.
Oh my good lord.
5,555,000.
Yeah,
What was it? Come again?
It's 555 931
931.
over 849.
Wow.
And then the decimal is like 65.45.
Okay.
So
That's less terrible.
Attention juniors, last names CH through GA. Please report to room 126 now. Again, that's juniors, last names CH through GA. Thank you.
Okay. I want to do one more and then we're going to call it quits. So those of you guys that are leaving, make sure that you get this example when you come back because this last one is a little bit, well, it's more exciting, I guess. More involved. It's not a terrible one.
Make sure you get this example when you come back.
Hurry. Okay, so we're going to start by drawing the base. So we have it in base that's enclosed by y equals 1 and then y equals x squared. So if I was going to draw y equals 1, what does that look like? Horizontal line at 1, right? And then if I was going to draw y equals x squared, what would that look like?
That's cool. Yep.
Parabola, right at 0. Okay, yeah, you guys are right with me. Okay, so this one is different than the other 3 questions that I have done because you guys check at this area. Okay, every example that I've done, the base has been touching the x-axis. Okay, so I haven't had to do a top minus a bottom. Okay, this one, for me to find the area of this one, I would have to do a top minus bottom. I would have to do a 1 minus my x squared, right?
Right, yeah.
Really?
Okay, so let's find the equation. Okay, so we're going to have cross sections that are equilateral triangles. Equilateral triangles. So, we're going to start by finding the area of an equilateral triangle. Does anybody know what the equation of an equilateral triangle is?
It's not on one.
It's not on my thing.
Is it base times 5?
The square root of 3 over 4 times s squared. So, yeah, right? Because usually we say the area of a triangle is 1/2 times base times height, right? But usually on an equilateral triangle, we only know the lengths of the sides. So let's say, I don't know, let's say it was x. Okay, remember that when you do an area of a triangle, it has to be perpendicular to that base length. So it ends up being a Pythagorean theorem. I could prove to you that that's the formula, but anyway, do you want me to show you how to do that, or do you just want to take my word for it?
I'll take your word for it.
Thanks. Okay, so we have little equilateral triangles, and I wish that this drawing was a little bit bigger, but let's use purple. Okay, so do you see that that's my little triangle that's going to come right here? Okay, so the base of my triangle is going to be that blue area. So tell me what the base of the triangle is going to be. So it's not, it's what? Well, what's the length of S? It's 1 if I was going to do right at 0, but what if I slide it over just a tad? Okay, so if I slide this over, I wish I could like totally zoom in on this, but what ends up happening is I have like, okay, here's your base, or I have a height of 2, no, what is my height of 1? But if I'm over here, I have a height of 1, but then I have to subtract out my x squared. So it's 1 minus x squared. So that's my s. 1 minus x squared. Okay, so when I go over here to this green equation, I can't draw. Because it's a top minus a bottom. There's a gap that's kind of cutting out of the bottom. Hold on, sorry, I can't draw. Pause. It's cleaning. There we go. Okay, so my S, it's not working again. Dang it. So it's the square root of 3/4. Can you guys read that? 3/4. I'm writing it over here. And then that's a parenthesis. So it's 1 minus x squared. Can you guys see that? I'm sorry, it's not working.
Square root of 3/4.
So it says the square root of 3/4 times the quantity of 1 minus x squared, and then there should be a squared because our base has to be squared. That looks really awesome. So if we do the integral, what the piece we're going to type into the calculator, my integral,
Is between 2 and 2.
so my integral is, well, what are the two x values that it exists between? -1 and 1. So my integral is going to exist. Here, I'll draw it right here. My integral exists between -1 and 1 of my area. So square root of 3/4, 1 minus x squared. Okay, does that one make sense? I think that is probably as like complicated as it's gonna get.